family, we talked about it, and I've talked about some of the reasons, but we really wanted to make a difference, and I underline the word positive here because, we get into, this mindset of conservation, conservation, conservation. We got to do less, got to leave a smaller footprint, we got to reduce our carbon footprint, reduce our, and you end up going, well, if life is about less, what is there? Not really, it's not a really motivating prospect, right? So when you put up solar panels, you're actually producing something. You're producing something positive, something from the sun, something that's going to be there tomorrow, next year, and 50 years from now. This is Ontario's mix, right? So third nuclear, 23%, so about a quarter of water, about 19% coal, 16% gas, and there you go. Renewables, wind, a couple of percentage points, right? So solar is not even, wouldn't even be the thickness of the line, right? So we're going to talk about two different solar things tonight. One is solar electricity, the other is solar hot water. Obviously the first thing you want to do is do what I was talking about. That's not the fun part, but is to cut consumption, right? I mean, reality is that consumption is not only the cheapest thing to do in terms of saving power, but it's the easiest thing to do. And so this is what it looks like on the roof, and these are the ones here, the panels like this. These are the electric panels. The ones that are steeper are the tubes that are the solar hot water tubes. It's one of the coming pictures. I'll show you how it's connected. But I tell you, the solar electric part, very straightforward. The utility requires you to be able to just disconnect the system from the grid at any time, so they can come here and do that themselves. So it's not tucked away inside the house, right? Now, so you see I've got 2 meters, and this is the way it works. I've got the dirty pipe right there. This is the pipe coming from the transformer that's in front of Roger's house. This is the feed of power into my house, right? And so what happens is, whatever's produced by the solar electric system goes here, and goes through this meter. Then, and actually there's the way the wiring is done, the cables come up here, and then there's some pieces of metal that go across the whole top. And so basically it comes here, there are pieces of metal that connect this, and they connect here, and they connect that there. So basically the power is flowing from here onto this bus. Now so it's at the same point that the utility feed is coming in. So now the question is, the house uses whatever the house uses. So if it's being produced here, anything that's being produced here has a choice, because at this point it can either go into the house or it can go back through here into Roger's house. I'm sucking in power, I'm using power, and this meter is running backwards, and it shows that it's running backwards, and and that means I'm producing, and I get paid for that. So I end up with a bill like this, which has where is it? So I've got one that says credit all the time, like this one, 542 credit, right? And the other bill says whatever I consume. And so this is from when? Was it May to July last year? So my electric bill, so consumption in the house, $236. What I got from here, $542. So and that's for a 2-month period, right? So I'm actually all summer, from about the spring all the way through to about end of September, I'm way ahead. You look at this, because this is the equipment I've got, so you can tell exactly when the dawn was, when sunset was, and you can see that going, right? But you can see that starting from about, 10 o'clock, 11 o'clock, it's producing more than what the consumption is in the house. You go, well, it's not just like on-off, or it's not light-dark. It's like you can see, okay, these were really rainy days. These were rain, partly, cloudy, sunny, and then look at this, right? Really dark, and then bright sun, rain, dark sun. So you see, holy smokes, it's a pretty variable situation, right? Saying the math for solar hot water is a lot better than the math for solar electric, right? Right, of course. And so when we put solar hot water on our roofs, basically what we're doing is we're putting these pipes on the roof, like you saw those round tubes, and so the sun heats the tube up, and you end up with colder water getting pumped out. It picks up the heat as it passes along the tubes. The hot water comes back. It goes through a coil that's inside a tank, and because the water is a lot hotter inside the coil, it's like a kettle, right? So it just radiates out and it heats the water in the tank. And then when you use the water out of the tank, you're drawing from the top of the tank, which is, of course, hot water goes to the top, the cold water sinks, so you end up drawing the hot water off the top. Yeah, so there's the tubes in the back, they're standing up for the peak winter, and the sun, flat solar electric panels for peak of the summer. So, and so instead of just heating this coil, it actually goes first out to the hot tub, sees if the hot tub needs heating, transfers its heat there, which means I don't have to use electricity to heat the hot tub. And it comes back, and I've got about enough to do both of those. And in the summer, because the summer, the heat is so strong, and I've got so many panels, and no one uses water in the summer, the hot tub is warm because it's warmer outside, so you don't have it set as high, plus it's not 40 below, so it doesn't lose all its heat. So all the extra heat I just dump into the pool. The piping, so there's water, so it's plumbing, right? So you can see the copper pipe coming along here, it comes to the beginning, and it goes all the way along all 4 of those sections, and then back down into the house. So 30 tubes in each of these sections, so there's 120 tubes out there, and there's these glass evacuated tubes. Oh, so here's one of the charts that I did for the water. So I used 3,400 liters of water for that month, whatever month it was, September, and 53 cubic feet. 53 cubic feet actually converts into, I would have been able to heat about a couple of hundred liters of water with this amount of gas. And so meanwhile I used 3,000 liters of water. Actually, interestingly enough, you can tell some of the days where there's sun and not sun. So you go, so the green is the gas consumption, and the blue is when hot water was used, right? So you can see, like, you go, okay, well, I used hot water, and I used quite a bit of gas. And you go, well, here I used even more hot water, but almost no gas. So obviously, I guess that was a sun. So this is percent of my total building use. So remember at night, and after the sun goes down, I'm sucking off the grid, right? So this is 55, 60%, 50, 60% of the whole day, right? So that means I'm producing an awful lot more actually during the day than I'm using. Like often 2 to 3 times what I'm actually using then, and then I'm just kind of drawing it back off the grid. So really, if you can think about it, you know, instead of having a battery in the basement that's storing the energy, you're using the grid as a battery. But the best thing about that is that someone else is using it on the grid, as opposed to if it was just in the battery, it's sitting there doing nothing. First of all, the panel from the manufacturer are warranted for 25 years. And the Department of Energy's reviews over the last 25 years are estimating that panels, even that they've had in for 25 years, have another 15 years of service. And that was the Ontario program is a guaranteed 80 cents for 20 years. Away from the first month that you've got it connected, you're getting more money in than you're paying on the interest and the loan. You start paying that back over and over and over again, and you don't have an electrical bill anymore. It actually gets even better than that, because there's this thing that we often don't think about in our personal lives, but obviously companies know all about this, and it's called depreciation. Right? And what this means is that money, that $45,000, is not gone money. You're considered by the government. You have a contract. You have a 20-year contract to produce power. So you are a power generator, just like Bruce Nuclear Power Station. And the way the math is done for renewable stuff is you get to depreciate that half every year. It's called a 50% depreciation. So basically, on my system, for 2008 tax year, I got my personal income reduced by $8,000. Right? So from a pure total investment point of view, 7 years. Right? 7 years, there you go. 8 years, 9 years. Break even. And so then it just cranks up year after year after year after year after that.